So in this video, which may be a little bit long, I'm going to do something that I don't normally like to do, and that is I'm going to create the rest of the doubly linked list totally live. Okay, I usually like to do a little bit of sketching out the program just so I don't get in the middle and get caught and make dumb mistakes and all that. But I really think at this point in the semester that it's worth seeing that process. It's worth seeing how you get yourself out of trouble if you get into trouble. Okay. So this is from the last video. We have our doubly linked list. Okay, so it's pretty basic. We just have a int for data. We're not doing any kinds of other types besides int, so no template stuff. We have a next, we have a previous, again doubly linked, and we already in the last video created our constructor. Okay, which just set the head and the tail, and head and the tail are all the member data that we have, pointer to the first and last element. Okay, and then we had this insert front function. Okay. And that insert front function is down here. And it takes an int value and it's going to create a new node here, our node type pointer, new node. Okay. It's then going to set the data equal to the value. It's going to set the next and the previous equal to the null pointers. Okay. And then if the head is equal to null pointer, okay, this is the head of the main list, not of the one we just created. Okay, then the list is empty, and we're going to set the tail equal to this new node we've created. Okay, if the list is not empty, then we're adding it to the beginning. So we're going to set the head previous back to the new node. Okay, and then we're going to make the new node next point to what is currently head, which will become the second element. And then we finally set head equal to the new node. Okay. And that should get that taken care of. Okay. The other thing I've done since last time, I've put a comment here at the top where I've copied from the program definition the functions that we need to add. Okay. So we're just going to kind of go through those and see, and I've deleted the ones we've already done. Okay. So I think the next thing to work on is this idea of a destructor. Okay, so the destructor or destructor is important because we want to make sure that when we are done with this class, okay, when it goes out of scope, that we clear all of the memory that we have used. Okay, so that's the basic idea there. And I think I'm going to go ahead and add the constructor here next to, sorry, the destructor next to the constructor here in the function body itself. Okay. So again, this is called just tilde. Let's see where I can type here. Tilde, okay, which is for me above the tab key, the name of the class. So this is doubly linked list. Okay. Takes no parameters. So for this one, the main idea is we have to create a pointer. We can call it current, what we've been doing. Okay. And we're going to iterate through the entire linked list and then delete each element as we go. Setting it equal to a temp node, moving current equal to current link, and then deleting it. Okay. So that's the basic idea. So I'm going to have to start with my node type pointer. Okay. Node type current. And I'll set that equal to head. That's my first thing we're doing. Okay. So we're at the first element. Okay. I can now go into a while loop and say while the current is not equal to the null pointer. Okay. So if the current is equal to the null pointer, it means we're at the end and we're done. Okay. So the first time through, this is going to point to the first node, then the second, then however many there are. Okay. So for each of those, okay, we're going to have a node type temp node equal to current. Okay, so I'm setting up um, a pointer to the node that current points to. Okay, and now that I've got that saved, so I'm not going to lose it, I can advance it forward by saying current is equal to current, um, not next. Is it next? It is next. Okay, we're doing, double check, we're doing next and previous, right? Next and previous. Yeah. Okay. I'm going to move it forward with that. Now the pointer goes to the next one, the current pointer, and I can now delete my temp node. Okay. Then once I'm done with all that, that will go until the end, until it hits null pointer, and then we're fine. Then finally, I have to set the head equal to null pointer and the tail equal to null pointer, just to clear things out. Okay, so that should be our destructor. Okay, so I'll stop at this point and I'll go ahead and compile it. It's not really going to do anything. That seems okay. Let's see, I think I have a test program. Did I? Doubly link list test. Yep. So if I do take a look at that, and there should be nothing. Yeah, this shouldn't, I shouldn't need to change that to test it. So let me go ahead and compile that one, and then I can A dot out that, and it doesn't cause any errors. So I think that's okay. It would cause a segmentation fault if I'd gone too far. I'm gonna go ahead and remove my star GCH just because it creates those big files that we don't need whenever I try to compile a .h file. Okay, let's go back to this. So now we can say that our destructor is out of the way. Okay. So I think the next thing, kind of as a way to make sure that that we actually our insert front that we have is working. Okay. Let's go ahead and do the print forward function. Okay. So this one, I'll need a prototype in here. Okay. So this will be a void function, a print forward. Okay. It takes no parameters, but it should be a constant function. Nothing should change because of this. Okay. I like to copy that. It's not such a big deal here, but it's a bigger deal if you don't have, or if you have parameters. Okay. So I can come down to here and paste it. But remember, I have to put it in the proper namespace. Okay, so that should be doubly linked list colon colon. Okay, and I can check the one here to make sure that's what we've got. We've got doubly linked list colon colon after the void before that. Okay, so I then have to remove that. Okay, so as before, and pretty much as always, we're going to need to get a current pointer. Okay, so I'm going to have my node type star current is equal to head. Okay, so we're going to start again because we're printing forward. Now, when we get to the print reverse, it's going to be the opposite. Okay, so again, we're going to have a while loop here. Okay, so while the current is not equal to null pointer, okay, which means we have something there. Okay, we can go ahead and see out current data, I'm calling it here, on a new line. Okay, and then we can follow the current is going to be equal to current next. Okay, and that should do it. Okay, as far as I can tell here. So let's see. Let's go out of there. We go ahead and compile that. No new errors. We go ahead and remove my GCH that it just created. Okay, let's take a look at my test program. Okay, so I'm not asking the user. I'm just going to type in some random data. Okay, I'm going to do an LST dot print forward. That's what we called it. Okay, now I can compile the test. Seems okay. Runs it. Okay, and because we're adding to the front each time, that in essence reverses the list. So I did a 5, 10, 15. The 5 gets put to the front, then the 10 gets put in front of it, and then the 15 gets put in front of that. Okay, so 15, 10, 5 is correct. That's what should be there. Okay. Again, if you have a segmentation fault, you can use the GDB debugger to figure out where it's at. And it's going to be something happening with the way, it's the wrong one. Go back to the header file. Something happening with the way that we're um, moving forward in our while loop. We're not stopping at the right point. Okay. So I'm going to call that one done as well. So our print forward is done. And while we're at it, I think I'm going to go ahead and make the print backwards, which should be really similar. I should be able to copy it and paste it over. Okay, so let's see. Okay, so let's go down here to our function prototypes, which are right here. Kill that one, yank it back, yank that back here. I'm going to make this one a print backwards. Okay. Is there an S on that? No, backward, no S. I was suspicious when I typed it. Okay, that's there. I can now go down, copy this. Okay, I'm going to change that to print backward. Note that we don't have to worry, or we don't have to make this recursive like we did for the single linked list because we have those previous pointers. Okay, so this time I'm going to set this to the tail. Okay, but every time instead of next, I'm going to do previous. Okay, I think that's all there is to it. Well, let's see. See if I mess something up. I'm just going to go into my test program. And after the print forward, I'm going to do a print backward. Okay. So far, so good. And I didn't put a space in there, but it's doing 15, 10, 5, and then 5, 10, 15. So we should be good. Okay. So now we can go back into our program. And that one is done. Print backwards is ready to go. Okay. So we now have a couple. So the insert back, I guess that's similar enough to the insert front, probably, that we can think about that. Okay. So actually, let me take a pause in the video. I'm going to find the image we have of a doubly linked list just so we can kind of see where we're at. Okay, so not that you'll notice, but there will be a pause. Okay, so I found the image here, so we can kind of get the idea of what we're looking at here. So for the insert tail, I'm going to just assume that this one was not added, so I have less redrawing to do. So let's say we're at this point. That is nothing. That is nothing. And this is that. Okay, so we create the new one. When we create it, okay, so this is going to be our new node here. Okay, so we're going to create the new node just like we did before. We'll set the values again as we did before. So no issues there. And we have to think about how we want to add that to the end before we rename tail. Okay, so that's going to be basically, we're going to need to set the tail next, okay, should be equal to the new node. Okay, that'll be good. And then we're also going to have to set the new node previous equal to tail, and then we can move tail. Okay, so I'm going to go ahead and make myself a little note here. Okay, I need to set the tail um, next equal to the new node. Okay, and then I need to set the new node previous equal to tail. And then finally, I can let tail be equal to new node. Okay. In fact, I'm going to go ahead and copy that. I'm going to stop the share here. I'm going to go back to my code. Okay. I can then, in my code, um, I'll have that available when I need to make a note here. So this is going to be the insert back is the next thing we're doing. Okay, so it's going to look like this. Void insert back int value. And then I can go down into my code and find that one. Here's the insert front. Okay, and this is going to be similar in some ways. So let me just go ahead and copy this all over. Maybe some excess, but may not. It'll provide some structure for me. So I've control K'd all that. Control Y to bring it back. Control Y again. But this is going to be, that was the insert front. This is going to be the insert back. Okay, we're going to create the new node as before. We're going to set the values as before. Nothing different there. Okay, so if the list is empty, okay, so it doesn't matter that we're adding to the front or the back because the list is empty. Okay, so we're going to set down here the new node head is equal to the new node. Okay, so that's not going to change any. But in this case, we're going to also set the tail equal to the new node. Okay, that's all we do there. But now the list is not empty. Let's go ahead. I'm going to paste over what I typed in before my notes. Again, I'm going to make it a comment just so we don't get lost here. Okay. So for this one, if we're at the list not being empty, okay, I'm going to set the tail next equal to the new node. Okay. And then we need to make sure we're down here, we're setting, okay, it's all gonna be different. Okay. So here we're going to have the tail next is equal to the new node. We're going to have the new node previous be equal to tail. Okay. And then here as well, we're going to let the tail be equal to the new node. Okay. So I've got tail next being equal to new node. I've got new node previous equal to tail, and then the tail is equal to the new node down here, which is true. I guess I'm just gonna make that redundant there because we're already doing it there. Um, I don't think we need. Oh, we do need to do something else. This is not correct. This needs to be the head gets set to the new node up here, and then in either case, the tail is going to be set to the new node here since we're adding it to the tail. Okay, and this ends the insert back. Okay, so that should be good. Okay, so let's run it and see. Again, I'm just going to go ahead and move to the test. And this time I'm going to, so at this point, just to keep track here, I should have a 15, I should have a 10, and I should have a 5 in my list. Okay. So to add something to the back, okay, I should have a 99. Let's just do a 99 here. Okay. So then the print forward should be 15, 10, 5, 99, and the print backward should be reversed. I'm going to go ahead and put in an end line there, just put a space. Okay. So let's see what we've got here. Okay. So we're going to compile. Nope, that was the edit. I want to compile it. So far, so good. We're going to run it. And did I not oh, I didn't actually insert. You know, you have to actually insert before it to work. So here's my lst dot insert back 99. Okay, let's see if that works. And now we have the 99. That works correctly. Okay. So this seems like so far so good. It seems like that we're on the right track on this, which I think is important. Okay. So now all we should have left to do, so I can mark this one out of the way, is the delete. Okay. So again, with the delete, we have the things we have to think about. So if you can imagine in your mind, or you can go back to a drawing you've made of the unordered or of the doubly linked lists. Okay. If we delete from the front, okay, so if when we start, if heads equal, um, or if the head previous is equal to null pointer, then we know we're at the front. Okay. What happens when we delete that one? Okay. And then at the tail, we have to think about, is it different there? Okay. And then we have to think about um, just the general case, or if we end up, if it's the only element, kind of what happens there. Okay. So we have to kind of think about those possibilities. Okay. So again, the cases are, and we need to put these in our code, right? We're deleting the head, what happens? We're deleting the tail, what happens? If we're deleting this one in the middle, what's going to happen? Okay. So that's kind of the idea. Okay. So we can go ahead and for this one, um, and again, we're making this a Boolean function. It could be a void as well, but the Boolean is just going to um, return a true or return a false based on whether or not it actually deleted it. Okay, which sometimes is a useful thing to do. Okay, so for this one, I can um, go down to here. And this is going to be a bool function. Delete value, int value. This is by value, not by position or anything. Okay. I can then copy that, move down to the bottom. And by, that's not the right, I want to yank, not copy. Okay, so I'll yank that back. And I've just messed it all up now, so I don't know why. So let me go back and get it again. It's interesting that it did that. Don't know why. I mean, there's not much to remember, but when it's complicated, I think it's worth copying it just so we don't end up with trouble. Okay, delete value. I'm not sure I copied it here. Didn't. Go down here. Okay, look like that, but I have to add in the namespace because I'm not defining it inside of the class directly. Okay, then I can just get rid of that. And then we can go from there. Okay. And it really all comes down to we have to search for the value first. Okay. And then if we found it, if we don't find it, then we return false. But if so, we have the case one that we're going to delete the head. We have case two, we're going to delete the tail. And then case three will be delete from the middle, basically. Okay. So when we're going to search for this, okay? So I guess before that, we have to think, well, what if the list is empty? Okay. How do we know if the list is empty? If head points to the null pointer, okay, we know that the list is empty. You can't return anything from an empty list, or you can't delete anything. So we're just going to return false. Okay. Put a message there if you want, but that's going to be the basic idea. Okay. We don't need an else there because if the if is true, it's gone. If not, it ignores it. Okay. So I'm going to not worry about an else for that. Okay. So I now have to worry about finding our value. Okay. So to do that, I'm going to set up, as we do all the time, our node type pointer current, set it to head. Hmm. Can I search from the back if I wanted because it's doubly linked list? You could, but that seems a little weird, so we won't do that. Okay. And then what I'm looking for here. So I'm doing a while here. Okay. I want to make sure that the current is not equal to null pointer. Okay. If current equals to null pointer, it means that I'm at the end of the list and I didn't find it. Okay. Um, so that's an issue we have to worry about. Okay. But I also want to make sure that current data is not equal to what we're looking for, right? Those are the two conditions that I want this to stop. Okay. So if we get to null pointer, we know that we failed. If we get to the current data being equal to the value we're looking for, okay, either of those. So again, when it's not equal, you keep going. So if it's the case that the current's equal to null pointer, we stop. Or if it's the case that the current data is equal to the value, we stop in either case. Okay. And then if those are not true, then we just have to move it forward and say current is equal to current next. Okay. That's all we're going to do there. Okay. So at this point, we've stopped. There's one of two cases. Okay. So if current is equal to equals to the null pointer, okay, that means we didn't find it. So we're going to return false. Again, you can do a message if you want. But in any case, the search failed. Okay. If it's the other case, so if we're here, current points to the node to be deleted. Okay. That's where we are. Okay. So now we can deal with our cases that we have. The first case, we want to see if um, we're dealing with the head. Okay. So current points to the one to delete. So if current is equal to head, then we know that we're trying to remove the head element, that we found what we were looking for, the very first one. Okay. So for this, um, what we have to do is that we have to move the list forward. Okay. But we have to make sure that we're deleting the space there. We don't want a memory leak. Okay. So let's go ahead and we've seen this before, okay, where we're creating our new node. Okay, so let's go back up to there on our new node. Okay, not a new node. We need a temp node. Didn't we have a temp node? Yeah, the destruct read a temp node. Okay, let's go back up to the destructor here. Okay, so we're creating this temp node here and deleting it. Okay, so we're gonna do the same thing here, so we can just go ahead and copy it. Okay. You can type it again if you like, but I like to minimize errors. I have code that's working. I'm going to reuse it. Okay, so I'm going to go back to here. Okay, we're in delete value. We're deleting the head. Oh, we don't have to worry about this. I'm deleting the head. Okay, because oh, we still do. No, that's not right. What I just said. We do need to worry about it. Okay, so let me yank this back. Okay, um, I can then set head equal to head next. Okay. That moves us forward. Okay. And let's think about what we're doing here. Um, I have to think about the head previous. Okay. The head previous. We've now moved to the next link in the node. Okay. So the head previous needs to go to null pointer. Okay. Okay. Oh, but I have to make sure this could be the only element. Okay. So let's say if head is not equal already to null pointer. Okay. If the head's equal to null pointer, we only had one element and we've deleted it. Okay. So that's what we have to worry about there. If that's true, we're going to set the head previous equal to null pointer. So we had at least one element there. That's fine. Okay. Else, our list is now empty. Okay. So I also would set the tail equal to the null pointer. Okay. So that should do it for that one. And now I can delete my temp node. Okay. I think that's got it. Okay. So again, we're deleting the head. We're doing our temp node equal to current because current equals head. I could say head there too. Doesn't matter. I'm going to move head to head next. Okay. And um, as long as head is not equal to null pointer, so there's nothing there, then the new head previous will go to a null pointer. It before would have pointed back to whatever the old head was. Okay. If it's empty, if it is equal to null pointer, the list is empty, and I'm going to set the tail equal to null pointer. In either case, I'm going to delete temp node. Okay. So let me go ahead and I am going to compile this one this time just to make sure I haven't introduced any new errors. Doesn't like something. On 171. Looks like I'm missing something, so let's find out. We go down to 171. the control V does that. Uh, oh yeah, right here. I'm not coming out of the if, and that was the trouble, I think. So let's see. Try it again. Compile it. Seems okay. I want to remove my star GCH, get rid of those big ugly files. Okay. So I think we're okay on that one. I don't want to test it until I've got more to do. Okay. So that is deleting the head. Okay. So now we can think about what it means to delete the tail. Okay. So in deleting the tail, okay, and these are a connected ones, so I need here an else if current is equal to the tail. Okay, this is actually this should be down there. Okay, down here I'm going to say so that ends. I can say else if current equal to tail. Space there. I don't need it, but I want it. Okay. So in this case, okay, so I'm getting rid of the tail. So I have to make sure I want to delete the node. So I have to do that again. But the basic conceptual idea is the tail previous is going to point, um, the tail will become tail previous, basically. And then the tail next will then become the null pointer because it's at the end. I think that's all I need to worry about. Okay. Um, if the if this were the only element, I would have found it at head, not tail. So I don't need to worry about am I going to an empty list, right? If it were an empty list, then deleting the head would have been where we're at. Okay. So I think we're covered there. Okay, so I'm gonna go ahead and copy this code so we can have it for the current. That's not what I wanted to copy. It's oh no, right. Temp node equal current. That's where we're at. Okay. So let me yank that back. Okay, so I'm capturing current as temp node. Okay. And now I can set tail being equal to tail previous. Okay. And then I can set tail next equal to null pointer. And that should do it, except I now need to delete temp node. Okay, so let me think. Let me try this one, make sure it works. See if I've forgotten something. Nope, that seems okay. So I'm going to go ahead and remove my GCH file. Okay. And now before we test it, let's do the last case, which I think is the most straightforward. Okay, so the last case is when we're somewhere in the middle. So the head and the tail are not going to be involved. And I think I had said in class that the delete does not need the two pointers, the current and the previous we've had to do with the single list, because we can get back to the previous with the previous link. Okay, so it's kind of built in. Okay, so we're now down to this case, and this is an else. This is all connected to this same. Okay, so we have the first if up here, the else if there, and the else. And you see the Emacs has lined it up properly so we see where things are. Okay. So this one is going to be, we're deleting the middle node. Okay. So again, I'm going to need a temp node so we can clear out our memory. Okay. Then, um, for this one, for the current, okay, so what I'm not, so the previous node, okay, so just so we're clear here, the previous node is going to be equal to current previous, okay? So I want to redirect its next to current next, okay? Probably worth taking a look at our picture again just to make sure we know where we're at. Do I still have that? Yeah, here. Okay, so we're deleting one in here. Okay, so let me make these back to black to see what we're wanting to change. Okay, and don't care about that. We don't have a new node at all, so I'll get rid of that. Okay. Stay there as that. That. I'm gonna move over to here. I'll get rid of the other pointer. So this is more what our normal, the normal run of things is going to be. Okay, get rid of that. So tail points over there. Head points up here. We don't care about either of those. Let's say, okay, then that's going to be not anything there. That's going to be back to normal on that. Okay, so let's say this is the one we're deleting. Okay, so I'm going to go ahead and fill that one with some different color. This is what we're deleting. Okay, so at this point in our code, current is going to point to that node. Okay, so that's kind of where we are. Current points here. So what I need to do, I need to remap this one, okay? But I need to point it where this one is, okay? So this node is current previous. So this red line is current previous next, okay? So I want to set current previous, which is the node containing 23. So I'm to that node. Now I want to set its next equal to current next. Okay. Um, I also need to take this node. So I need this, make a different color. That one also needs to be reset. Okay. So to whatever this one was. Okay. So this is going to say current next previous. Okay. Current next is the one with the 12. We don't care that it's tail. We want its previous, that's the light green one there. We want it to be equal to the current previous. Okay. That looks very confusing and would be very difficult to figure out if we didn't have a picture. And let's hope we've got it right. Okay, so I'm going to copy that. I'm going to go back to our code and hope we don't lose our mind, because we may. Okay. So I'm now in this spot in my code. So if I paste that in, it should just paste in okay. I need the semicolons. Okay. And again, this current previous just refers to um, the previous node to current, and this is the next node. Okay. And we're setting up these. And if I've done this correctly, we should be good. And then finally, we can delete our temp node. Okay. And we may be done. We'll see. How bad can it be? Okay. So let me take a look here. I'm going to compile that and see. We're still good on that. Remove that. Okay. So now let's look at our test program. Okay. So I don't think I care about testing the print backwards at this point. Now, when you turn in your homework, you want to test all your functions, but I'm just going to worry about the one I'm worried doing now. Okay, so at this point, we have the 15, the 10, the 5, and the 99 is our order. Okay, so if I want to say delete node, let's say we're going to delete the 15. Okay, let's test the head. Then we're going to print it forward and see what it does. Okay, so I'm going to go ahead and actually do a print forward before and after I delete the note. See if that works. Okay, compile that. Doesn't like something. Did I call it delete node? What did I call it? That becomes the delete value. There we go. And if you notice, the error message showed me that, which is useful. Okay. So yeah, right here it tells you, is this what you meant, basically? Okay. It doesn't like something about 185 about there's a warning there. I'll take a look at that to see if that's an issue that we have to deal with. Oh, I'm not returning the true. That's what my issue is. So that is an issue. Okay. So let's fix that before we go any further. Okay. So again, since that's a Boolean function, go all the way to the bottom. I should use my control V, but I'm not going to. Okay. So we're returning false here. Okay. If there's nothing there. Okay. In this case, we were able to do it, so we have to do, we don't need to do it there because in either of any of these cases, this case or this case or this case, in all three of those cases, we should return true. Okay, should do it there. So let's compile our test again. We don't get the warning. We don't get anything. We should be okay. Let me run it. Okay. And I need to put a space in there, but it looks okay. So let me, yeah, your test programs, you should take more time than I do. Should be meaningful when I'm testing your programs, but also it'll help you. Okay, so um, I just want to put in something like list after deleting head. Okay, that looked like it worked, but let's make sure. Okay, so there's the 15, 10, 599, which is correct. We now have deleted the head. Life's good. Okay. So let's go back in. And again, you should keep all these tests in there, but I'm gonna not do that. I'm gonna replace my test and I'm going to delete the tail, which is 99. So this should be after deleting the tail. Okay. Compile it. Run it. Okay. We had 10 We had 15, 10, 5, 99. That didn't do it. Did I not call the correct function? Did I not recompile? Let me check both of those things because it still deleted the head. Okay, so look at this. No, I should be deleting 99. Don't know why it's not doing that. Maybe I didn't compile it. Let's see. That's a very interesting problem if that's really the problem. No, it is in fact still deleting the first one. Um, don't know about that. I'll have to look that one up. I'll have to look at our code in a minute. Well, let's test our last one just so we can see where our problem, see if that is a problem as well. Maybe we always delete the first one. Not sure why. Okay, so this time we're going to delete the 10. Okay. Now it's after deleting 10. Okay, so let's see if that does anything. Okay, I'm going to compile it. Going to run it. It did not delete the 10. It's always okay. This tells me that I'm always falling into that first case, no matter what. So my guess at this point is that it's because I probably have a single equals instead of a double equals on that first one. Just a guess. Let's see. So go back to the header file, go down to here, and in fact, that's the case. Okay. So because that was a single equals, it was an assignment, not asking a question. I wish it would give you a warning for that, but it doesn't, which means this was always true. Every single time we did it, it was true. So that's the only thing I could think of that would make it always delete the head no matter what. Okay. So let's deal with this one now. I think life is good, but we never know till we test it. That is correctly deleting the 10. Okay. And see if I would have taken the time, I wouldn't have had to do all these tests again, but I didn't. Okay, so now let's instead delete the 15, which is the head. And that was working before. Hopefully it's still working. Yep, that deleted the 15. That's good. Now let's go back and check on deleting the 99, or deleting the tail. And I've got good feelings about it. Okay, so let's run that again. Yep, looks okay. So the only thing we have left to test, we have left to test if there's only one element. Okay, so in this case, it would be, again, I would keep all this code in your test to test everything, but I'm not going to do that. And then 5, it should be empty and it shouldn't really print anything at all. Let's see if this causes any great disturbance in the force. Okay, that's good. We had a 5, did nothing. Okay. Note, I'm not here testing the true and false. Okay, so if I have nothing at all, or let's see if we don't find it. Okay, so let's go ahead and say there's a 15 there, and we try to delete a 5. Shouldn't make any difference at all. Okay, didn't delete anything, and that's correct. Okay, and what we could add to our test, which we didn't, um, if that, since that's a Boolean, cout item deleted, else See out, item not found. Okay, so try it on this one. Item not found in that one, which is correct. And let's try it one more time. If we delete something that's really there, so let's insert 15. Let's do a 5 and a 15, doesn't really matter. And then when we go to delete the 5, it should be there. Item deleted. Okay. So I think we're good. So I think that is the correct code. Okay. So I think we have here, we've now dealt with this. I can get rid of that stuff. Okay. So I've gone through one by one, and this is how I would do it, right? It's how I did it. I mean, I did it live and didn't make too many errors. Um, I referred to the drawing. If I were coding this, I would print it out or draw one on a piece of paper, have it with me all the time, so you can work out those pointers. Okay. I copied over the description of the functions. I worked on them one by one, tested every time. Okay. So we added the destructor today, okay, which was new. We already had the insert front from the previous videos. We added the insert back. Okay. We put some um, comments in there along the way. Okay. We don't necessarily need this stuff. That's a little ugly. That's one of the comments we moved over. Okay. We had the print forward. No, I think we added the print forward. Then we added the print backward, which is very similar. The delete. Okay. We have the different cases we have to worry about. So we added all that. That was the last one we added. And we tested out in our program and seems to work. Okay. So this was a long video. Hopefully you'll watch it all the way through. It was a pain to make, kind of, and it'll be a pain to watch, but I think it's important um, to model how to go about creating a file like this, okay? To go through the whole process, errors and all, okay? So if you have questions about any of this, let me know.